Okay, so like I said, today we're going to be talking about function notation. And if you guys remember from that very first introduction video that I had you watch, it was on there. It was that weird F with the parentheses X. Does that ring a bell a little bit? So let's go ahead and write today's date. Wednesday, September 23rd. Function notation. It's pretty exciting stuff. I don't know why somebody decided that we needed a new way to show what y was, but they did. So we just follow the rules, right? We don't make them, we just follow them. So we do have some vocabulary. Function notation. And that is literally this F parentheses X parentheses. Okay, so like I said, it kind of just takes the place of y. So previously, you would see y equals mx plus b, right? Everybody's favorite equation. Who remembers what the m is? Slope. What's the b? Y-intercept. And then we have our input and our output, right? So based on what our input is, that affects our output. That's the same thing. So now we're just going to do function of x equals mx plus b. Okay, so we literally are just replacing the y with a new, right? All of math is like letters and numbers used as symbols. So we're just replacing this y with this f of x. Okay, right? It doesn't change that when we input something, our output is still y. We're just calling it the function of x now. Like, what did we do to x? Here's our answer. Okay, so nothing changes. So we're going to write here, hold on a second. This is the function of x. Nothing changes mathematically. Okay, so we don't do anything different with our math brains. We're just using a different symbol. So now let's apply that. So we've got this function here, f of x equals negative 4x plus 7. And we're going to say what happens when x equals 2 or x equals negative 2. Okay, so this is probably one of the biggest obstacles to overcome, like with your train of thought, is that when students see this, they want to solve something. We're not solving anything. We're just substituting and getting a new value. So we're not solving for x. I told you what x was. What we're doing is we're substituting to find out what y is. We don't have to do any inverse operations. We don't have to do any rearranging. Really, we're just substituting like you've been doing since probably like first grade, right? What plus 5 equals 10, and you're like, 5. Okay, you were doing algebra, basically, in like second or first grade. Okay, I see my kids' homework. It's basic, but it's kind of algebra. So what this will look like is the function of 2 equals, right? So what I'm doing is I'm telling everybody, I know that I'm putting 2 where x was. So I'm just going to put that 2 in there. Negative 4 times 2 plus 7. So then I would say the function of 2 equals what? So when I use 2 in my function, what will the function equal? Atlee? Negative 1. Right? Again, math isn't changing, just the way it looks is changing. So what would be the function of negative 2? So I'm going to put that negative 2 in where x was and add 7. So what's the function of negative 2? Ethan? 15. Because negative 4 times negative 2 is positive 8 plus 7 is 15. Let's try another example. Function of x equals 2x plus 5. So what's going to be the function of 4? What am I going to do mathematically with that 4? Where's it going to go? Atlee? Yeah, I'm going to put it in here where x was. And so what will the function of 4 be? Adam? 9. A little bit higher than 9. So we don't do anything with over here. I just want to know what's 2 times 4 plus 5. Adam?
2 plus 4 plus 5 is 13.
2 times 4 plus 5 is 13. Yes. Right? So again, I think what you probably did was you got 13 and then you subtracted the 4, but we don't have to do that. This is just telling everybody, hey, this is what number I put in for x, but I don't actually then do anything with that value. Okay? So what if I have the function of 0? What will that be? Ben?
5.
5. Right? Because 2 times 0 plus 5 is 5. All right, we'll do one more. Sometimes they like to get really creative and put a different letter instead of F, which doesn't make sense to me because I've always thought that F stood for the word function. But they'll go ahead and put like a G, an H, an R. I don't know. They just want to keep you on your toes. Don't let that distract you. You do the exact same thing. So if I'm finding, and you still say function of x, which is so weird. So if I have negative 6x plus 3, so what would be the function of 1/2 or the function of 1/3? So what am I going to do with that 1/2? Where is it going to go? Olivia R? Where x is. So negative 6 times 1/2 plus 3. What's the, oops, see, look at that. I wanted to put an F there. What is the function of 1/2? What's your answer going to be? Bryce?
0.
0, right? Because negative 6 times 1/2 is negative 3 plus 3 is a nice even 0. And how about the function of 1/3? Where's the 1/3 going to go? Katie, what do you think? Great. So what is the function of 1/3? Who haven't I heard from? Nathan, what's it going to be? 1. Great. Because -6 times 1/3 is -2, plus 3 is 1. How are we feeling about function notation so far? Not terrible. You just have to kind of train your brain not to do anything with these numbers, and also to be like, okay, whatever. They just wanted to be fancy, right? Okay, so let's interpret function notation. So this was evaluating it, right? Putting the numbers in, substituting. Now we're going to actually apply function notation to some scenarios, okay? I'm just going to write this up here and then we'll talk about it. Okay, so let the function of T be the outside temperature, 0 degrees Fahrenheit, T hours after 6 a.m. Explain the meaning. So that probably looks like gibberish to you guys, but once we start applying it, you'll be like, oh, that's not so bad. Right now it just looks like gibberish. How many of you abbreviated this to temp and put T-E-M-P? Did anybody do that? Yeah? So do you want to know a funny story about why I always write out temperature? Sure, why not? We'll tell stories. Okay, so 5th grade, I'm doing a science project, right? My science teacher, Miss Craig, we used to switch for science. Miss Craig had us do this really long project, and in my report, because we would write a little report, remember those like things that would have like plastic, and you'd have that like little hard plastic, the thing you would like slide it up on there, so it was like report covers. You guys ever seen those?
Yeah.
Like in old movies and things, probably. Okay, so throughout my entire report, I abbreviated temperature to the word temp, and she just completely annihilated me in front of the whole class. She never said my name, but she talked for a very long time about how we do not abbreviate words in science documents for a very long time. So I will never abbreviate the word temp.
She gave you an F?
Well, I didn't get an F, but I didn't get an A. And a lot of it was because she just kept taking points off every time she saw the word temp. She wasn't a very nice teacher. She wasn't my like 5th grade teacher. She was just who I had science for that rotation at that time.
You should have sued her.
I mean, no. You can't sue your teacher.
$1 million for each point she did wrong.
Yeah, I don't think I would have gotten very far. Because remember, she's a teacher. So she probably didn't, I mean, who am I going to get that money from? Right? Teachers don't have millions of dollars laying around. As hard as that is to believe. Right? Bank accounts, other people's accounts. Okay, so let's get back to this. Thanks for listening to my 5th grade. I mean, it didn't harm me at all, right? I'm still talking about it 30 years later. It's Craig, 5th grade. People don't forget. Okay, so let's look at these examples. So the function of 0 equals 58. What does that actually mean? So if this T represents the hours after 6 a.m. of what the temperature is, who can tell me what this means? What does this actually mean? Allie? 58 degrees temperature, Fahrenheit, right? So this actually means at 6 a.m. it's 58 degrees. Because if we don't have any time after 6 a.m., that's just the temperature at 6 a.m. Try another one. Function of 6 equals 72. So what is that telling me? What does that mean? Ethan?
6 hours after 6 a.m. and 72 degrees.
Okay, so what time is that?
1 p.m. Oh, wait, no, 12 p.m.
Yeah, it's noon, right? At noon, it's 72 degrees Fahrenheit. So this one's kind of weird. The function of 3 is less than the function of 9. See if I can get that to not be as glary. What does that tell us? What does that mean? Adam?
It is colder at 9 a.m. than it was at 3 p.m.
Yeah, exactly. How did you know this was 9 a.m.?
Because 3 hours after 6 a.m. is 9 a.m. And 9 hours after 6 a.m. is 3 p.m.
Great. So you could say it's colder at 9 a.m. than 3 p.m. Or how else could you interpret that? And it'd be saying the same thing, just to maybe your mind goes to this rather than that. What do you think, Bryce?
3 p.m. is warmer
Yeah.
than 9 a.m.
So if this was a quiz and I was asking you to interpret those, I would accept both those answers, right? It's just how you're looking at it. Both things are true. All right, now we're going to get to some serious business. We're going to talk about Starbucks. So our second example, suppose f of x equals negative 4x plus 100. Suppose that function represents the amount remaining on a gift card after purchasing X chai tea lattes at Starbucks. So that's going to be our scenario for this one. This may or may not be accurate. It's accurate. I go to Starbucks every day. It's accurate. It's true. It's actually like $4.02, but we're not gonna get crazy for this example.
What size do you get?
I get a tall. I spend $4 on a drink.
Does it have ice in it?
It doesn't. It's
Oh, that's good.
yeah. It's no. You're right. It doesn't. And I also so you have to get it down to a science, right? Like so you have to say no foam, so you get the most amount, right? Otherwise they put like this much foam at the top, and you're like, where's
Where's my drink?
I paid for $4 and I'm getting $3 worth of a drink, so that's not good, right? I've actually, has anyone ever taken a drink back to the barista and been like, this isn't accurate? I don't feel bad about it anymore when I'm spending that much money for a drink. What did you take back, Katie?
So I they completely just got my order completely wrong, and I wasn't just gonna sit there and say okay.
No,
And
not when
my
you're.
friend heard was completely wrong, and she was too scared, and I was like, man, I don't want to be a Karen, but you paid that much.
Yeah.
So.
You don't, I mean, that's not being a Karen. Not when you're actually spending that much money.
If you're respectful to the people.
Yeah, if you're nice about it. They don't.
People know my name, like they know my name.
Yeah.
Like,
Which
that's
one do you go
awesome.
to?
So there's like one right next to my dance studio. So on our breaks together, it's like Meridian,
Mhm.
something like that.
Okay. Very cool. Yeah. What did you take back, Atlee?
One time I asked for like a drink blended, but they didn't give it to me blended. So
That's not
my
how.
mom made me take it back.
I I mean, you're not, again, it's not like it's a cheap drink. Like, you're spending money. It should be the way you want it, right? And as long as you're not rude about it, they don't care. They'll make you another drink. They want it to be, their sign says they want it to be right. I believe them, right? Ethan?
I took back something, like, so McDonald's, I asked for 40 chicken nuggets, they gave me 20, and it was like $600, so I had to go back and say I wanted 40.
I have, and I have an interesting McDonald's story. We'll save that for a different day. But yeah, I feel ya. McDonald's, sometimes they're in a hurry, right? People need their nuggets. So, okay. Adam?
There was one time, this was also McDonald's. A hot tip, if you go to a McDonald's that is also a Love's gas station,
Mm-hmm.
go away.
Okay.
Go
Yeah,
far away.
most combo gas station restaurants, nothing good comes of that.
So the tables were filled with dried up soda.
Yeah.
So were the seats. My dad had a gift card for McDonald's that expired in a week, and the cashier said he couldn't use it because it expired in a week.
Yeah.
And I got an orange Fanta,
Uh-huh.
and it came with lots of hair in it.
Okay. Yeah, you're gonna I'm telling you, nothing good. Now, I say that, but like rest stops, like if it's like one of those rest stops that has lots of different restaurants, that's okay. But if it's just a gas station with like a McDonald's or a Taco Bell or something, don't do it.
Check
Right?
the restaurant rating before you go in.
Okay, so let's talk about my chai tea latte situation. So one of the things you're going to need to do on your study guide, also quiz, is tell me what a reasonable domain might be. Okay, so remember, domain is all the possible x values, right? So given this scenario, what could my x values be? And there is a limit. There's a range. There's like a definite this through this. What do you think my possible range values could be? Bryce?
Wasn't it like -2, -1, 0, 1, 2?
Okay, so that's if I'm just like making a T-chart and I'm just trying to see if it's, good memory. But given this situation, what could my possible x values be? What do you think, Ethan?
That's Starbucks, $4 to $7.
Okay, that's how much I might pay for a drink, but take it back to this function right here. What could my x value be? What numbers could my x value be? What do you think, Atlee? Okay, so the -4 is how much I pay per drink, and I have a gift card worth $100. So I could either buy 0 drinks, or how many drinks can I get total? How many I'm sorry? Well, I have $100, but each drink is worth 4. So how many times can I go get that same drink? What do you think, Olivia? 25. So that's going to be my reasonable domain. Somewhere between 0 and 25 is the limit based on this gift card. Now, we all know that Starbucks will, happily link it to my credit card and let me buy more, right? Because they're cool, right? And they know that I'm going to do it. So, okay, so there's my reasonable domain. And then, what does this mean? That just means I have 25 days of awesomeness, right? So this means I can purchase between 0 and 25 drinks, okay? That's what that means. So if I wanted you to find the reasonable domain, of course I want you to find the reasonable range. So remember, the range is our y values. And remember, we're using this f of x to take the place of that y. Okay, so what would my possible y values be every time I order a drink? What could they? If I order one drink, what's my y value?
Your y value if you order one drink is going to be 4.
Not quite. I'm going to put 1 in for x, multiply times 4, and then combine, and then take that away from 100.
Oh,
Yes.
96.
96. Then what will be the next one?
So the y would be your balance on the
The y is your balance on the card. Yeah. So I could start out with $100, and then 96, and then 92. And I just have to establish a pattern. I'm not going to make you guys write out all 25 potential balance, right? And so then you just show me that there's a pattern, dot, 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 all the way down to 0, which is when you have to reload your card and you feel bad for like 2 seconds, and then you get your drink and you don't feel bad anymore, right? So what does this represent? And Ben put it perfectly. The balance on the card. You guys understand that word balance, right? The leftovers. Okay. So what I'm going to do now is pass out your study guide for your quiz on Friday. Everything you need to be successful on this study guide, and then of course be successful on your quiz, is in your jam. Okay, all of the information is there in your jam, waiting to be used again as a resource. Okay, there's nothing more frustrating as a math teacher when students come in and they tell me how difficult the study guide is. And so my question is, well, did you use your jam? And they say, no. And I say, what? Why didn't you use it? Okay.